Right, hello. Today I'm going to explain to you what unique prime factorisation is and how to find the unique prime factors of a different integer. So first of all, we'll break down what all these terms mean. A factor is a number that when you divide it by another number, it leaves a whole answer. It's easy probably to see this as an example. Like we can think about the factors of 12. Well, 12 can be written as 1 times 2. 1 times 2, 1 times 12, 2 times 6, or 3 times 4. So all of these numbers, 1, 2, 3, 4, 6, and 12, are the factors of 12. Any number that you can multiply by another integer and you get that number out. Prime numbers then are special types of integers with only two factors. Only two factors, and one of these factors will be themselves and the other one will be 1. So a good example is 7, because we can only write 7 as 1 times 7. We can't write it as 2 times anything, 3 times anything, 4 times anything, 5, 6, 7, etc. We can, but we need them to be integers, so it doesn't work. They have to be integers. And the idea of factorisation then is we're going to be splitting up a number into its factors. Unique then means there's only one way of doing it. So what we're saying is, for every integer, there's one and only one way of writing it down in terms as a multiple of primes. So we'll think about the method of how we're gonna actually figure this out. Like how do we find the prime factors of a number? We'll start with 12 actually and do a really simple one. So 12. We know straight away we can do 2 times 6. So 2 and 6. And then we look at 6 and we think, well, that can be 2 times 3. And what we have at the end then is all prime numbers. So straight away we can see that 12 is equal to 2 times 2 times 3, which is very nice. Sometimes you might write this as 2 squared times 3. Either answer is correct. It can be a little bit neater to write it like this. So it can be useful sometimes when you're doing these problems just to write out the primes. So we'll have 2, 3, 5, 7, 11, 13, 17, 19. You won't really encounter them much higher than this, but it can be useful to know the first couple. So let's pick some numbers. We'll have 66 and have a look at that. So 66, we can see it's an even number, so we can do 2 straight away. And to get to, well, the 2 times what gives us 66? It's going to be 33. Looking at 33 now then, it's not a multiple of 2, so we move on to the next prime number, and we'll have a look at 3. 3 is definitely a prime number. It's definitely a factor of 33, and it's going to be 3 times 11. And what we see then is 11 is in the list, so we're done here with all the prime factors. So 66 is equal to 2 times 3 times 11. Have a look at another example. We'll do 84. So I have picked these numbers beforehand, so they're going to give nice, easy ways of doing it. Sometimes what you'll see is like you've got a really big number, and it has a factor of like 2, and then just another prime number that might be like a really large one, like 57 or something. And in that case, it's still correct, like you're still done the same process, but there won't be that many steps. So I've chosen numbers here where we should have a lot of prime factors, so you can see a lot of steps and different ways that things come up. So 84 then, it is an even number, so we can tell straight away that we're going to have 2. And 2 times what then? So 42 in this case. To get 2 times 4 should make 84. You see all the way through, like where you've got them side by side, that 3 times 11 makes 33. 2 times 33 makes 66. So it should always follow that pattern. Same up here, 2 times 3 makes 6. 2 times 6 makes 12. So you can kind of rebuild the number. And that's exactly what we're saying. That's what we were trying to figure out. Like what different bits do we need at the bottom to build up back to the original number. 42 is even. So we can use 2 again. And it's going to be 2 times 21. Very nice indeed. 21 now isn't even. So we look at the next prime number. There's no reason you have to do this in order, but it kind of makes sense because you don't just want to think, okay, I'll start with 19. So it's a factor of 19. You could do it that way, but it's generally better to do it systematically and start with the lowest prime and work your way through. 21 then, let's try 3. Well, yeah, we can have 3 times 7. Very nice. And what we see now is 7 is a prime number, so we're done. We've reached the last prime. There's no point carrying on here. Like, I think this is why 1 isn't a prime, because we could just always do like 1 and 7. 1 and 7. And it just kind of would be pointless doing that. So we don't want to ever do that. So what we're left with is 2, 2, 3, and 7. So 84, as its unique prime factorisation, is 2 squared times by 3 times by 7. Do one more example, just to clarify a little bit more. We'll do a bigger number. We'll do 910. So straight away you can see it's even again. So we're going to have 2 times by something. Well, 900 would be 450. So we've got 4, 5, 5. Sometimes it can be useful to see that this is a 5. We might do that straight away just to make it a little bit easier and just jump ahead. But then remember, we're still on 2 or we're still on 3, whichever one we're going to be. And just going back to it again. So like, it can be easier to think about it in this terms. But first of all, we'll check, is it a multiple of 3? The quick check for that is to add them all up and see if that is a multiple of 3. So 5 plus 5 plus 4 gives us 14. That's not a multiple of 3. So this number 455 is also not a multiple of 3. So we'll move on then to the next prime number, which is going to be 5. Well, we can see it's 5 times something. Well, it's less than 100, but it's bigger than 80. So we had, well, 5 times 9 would be 45. So it's going to be 91 in this case. This is something like you can do your little division over here if you want to. If you can do it in your head, even better. And you can always check at the end by putting this back in a calculator and making sure that you get this out, or by doing this multiplication. So 91 then, let's think about what numbers are factors of 91. 5, no, it's got a 1 on the end, so it's not going to be 5. So we'll move on to 7. And 7, we'd have 70 plus 21 would give us 91. And those are both multiples of 7. So we can say straight away that 91 is a multiple of 7. And it's going to have 13 on the other side. 13 is a prime number, so we're done. Beautiful. So we can say is 910 is equal to 2 times 5 times 7 times 13. Very nice indeed.